Hi, everyone. So welcome to the EDCON Hack, a live online workshop that is moderated and facilitated by CryptoChicks. The topics for today is Cryptoeconomics for Plasma by Karl Floersch, a deployer on Plasma chain. The workshop will last 1 hour. You will have a 40 minutes lecture by Karl and then 20 minutes QA after the lecture. You all will be on mute, but you will be asking the questions through chat. So there is a button at the bottom of your screen, the chat button, and you can ask your questions. Karl will answer it at the end of the workshop. So the workshop is about to start. Let's welcome Karl. So Karl, it's all yours.
Hello. All right, thank you very much. Hello, everyone. I'm going to share my screen. And at some point we'll be able to talk and you won't be on mute, and hopefully I'll see all of you at conferences or something like that. Anyway, let's dive right in. So I'm going to be essentially showing y'all how to deploy your own plasma chains. Now, I don't know if everyone got the memo, but if you do have Node installed, I put together a little GitHub gist for us to essentially, you can follow and you can kind of like deploy your own plasma chain as I'm deploying my own plasma chain and going through kind of lectures that show how everything works. So if, this GitHub gist could be shared, I just sent it to Elena, but I think I'm only allowed to send Elena private messages. At least that's how it seems. So would be, great. I think you sent it to me privately. Hopefully the chat stuff works. But while that is getting figured out, I will get started. So Plasma Group, you can actually check out Plasma Group, plasma.group. This is a kind of open source project. Ben, Jing, Kelvin, myself have been kind of spearheading it, but it's a kind of community effort to create a Plasma implementation that everyone can use. So what is a Plasma chain? Well, it is a non-custodial blockchain. What does that mean? Well, it is secured. Why is it non-custodial? Well, it's secured by Ethereum, the Ethereum main chain. And so Ethereum accounts retain custody of funds, and it's secured by Ethereum's proof of work consensus. But, don't trust me. You can check out the security assumptions here, although actually don't go on that link yet because I have to fill it out. This was, there will be a link to all of the security assumptions soon. So anyway, here on the left, we see the Ethereum main chain. By the way, please do send messages and ask questions. Personally, I feel like it'll be boring if I'm just talking to myself. I'm almost sad that I can't hear y'all voices, but it's okay. Anyway, so here's the main end. We have our miner, and it's creating some blocks. And so everything is going well. And so in this context, Plasma will be secure. When the Ethereum main chain is secure, Plasma is secure. But if Ethereum were to break, yes, Plasma's guarantees go away. But hopefully that doesn't happen. And that is essentially what Ethereum provides. If Ethereum was broken, then there'd be a lot bigger problems than just Plasma being broken. So that if Ethereum is secure, that means Plasma is secure, or these Plasma chains. And of course, there is the caveat where there is a extra synchrony assumption with the Plasma exit game, which you can look into, and I'm actually going to discuss later on. So it's a little bit more caveat, a little bit more of a caveat. This is true for layer 2 solutions. So it's an Ethereum scaling solution, really. What it is. Okay, great. And really it's a blockchain scaling solution, not just Ethereum. So there's, many Plasma chains potentially, and each one of them can scale, actually larger than the Ethereum main chain. And so I can actually even, talk about that later in Q&A or something. But that is a lot of, hocus pocus, it probably feels like, that's enough magic technology that's indistinguishable from magic. So let's look at the actual code. So first, we are going to do 4 things. We are going to deploy a plasma chain, then we're going to deposit into the chain, then we're going to send a transaction, and we're going to talk about what if something goes wrong. So first thing we're going to do is npm install -g plasma chain. So everyone who wants to follow along with me, please npm install. So I'm going to go into my terminal. I use tmux. I'm also afraid that people are going to learn about how I use my computer and then hack me. So hopefully no one here who is watching is looking for security vulnerabilities. Please don't do that. So anyway, I'm installing the plasma chain. So what does that do? You can also, by the way, install it locally. You don't have to do the kind of global npm install. That's kind of just up to you. And so when it's finished, it will say so, and we'll go back there. So let's see, it'll probably take another minute. So let's go over what our next step is. So first we're going to create a new account on using the plasma chain operator code. So just, create account new, and then we'll add in a password, and, everything will be fine and dandy. So this is still going through. And what will happen is, well, I guess I'll just wait here, pause for a moment. Any questions so far? Actually, someone send a chat message generally. I'm curious if it actually works. Just say hi, and I'll shout your name out or not if you don't want. Testing, yay. How's it going, Goldman? Hey, yay, a lot of people. Don't message, if someone messaged me privately, you might as well message it to the group. But anyway, okay, so it is installing. These crazy installation messages are because of Web3. Web3 is just kind of crazy, to be honest. Like, it has a lot of ridiculous dependencies that it does not need. Maybe. I shouldn't really talk anything about Web3. I haven't contributed to it. I should just fix it myself. LevelDB, this is the database that we're using in the operator, and also actually in the client. And LevelDB is pretty great. It's what's used in Ethereum and a lot of Bitcoin clients. It's just a staple in the industry. It's actually what is behind the browser database IndexedDB, apparently, according to Stack Overflow questions that I've read. Now it is still installing. And so many warnings. Promise you it wasn't my fault. Okay, so great. Plasma chain account new, just like I promised. We are going to set a very secure password. It is test. And then I'm going to send myself some ETH. So testnet ETH, this is very important. I don't know if, that is a very good point. I don't know if y'all have submitted your addresses to this GitHub gist. But hopefully you have, and I can send some people a bunch of testnet ETH, and you can kind of like spread it around, hopefully. So I'm going to actually open up the GitHub gist, which has the kind of Plasma workshop resources. And so you have a link to all of the slides. This is what was in the chat. All of the different repos and the steps to follow, and also just getting Rinkeby testnet ETH. So actually submit comments here. I'll actually refresh. Submit comments here with your Rinkeby address, and I'll just send people a bunch of Rinkeby ETH, or you can get it on your own, or you came with Rinkeby ETH, whatever. Help your friends out. We're all on the same team. Great. So let's see. Account new, fantastic. And we are going to, I think that our transaction may have gone through, but we will have to check that. I will retry with a higher gas price, although it looks like it may have gone through actually. Fantastic. Okay, so we have ETH. Now we are going to deploy a new Plasma chain. Very exciting. So I'm going to call this Plasma chain deploy, and we'll go over what that is actually doing here. So on the Rinkeby testnet, we have the Plasma Network Registry. The Plasma Network Registry has So I just got a question. What is the testnet ETH going to be used for? It's going to be used to deploy a new Plasma chain and also submit periodic blocks to the Ethereum main chain. So essentially what that means is, we need ETH for the gas to basically use the Ethereum main network. And that's what gives us our security. Otherwise, we're just like another lame old sidechain. So there is this Plasma Network Registry. And what we can see is we can actually go, there's a list of all of the Plasma chains that have been deployed thus far. And if we call Plasma chain list, we'll actually see this full list. So if I were to go here, I will actually see the full list of Plasma chains. So here, Plasma chain list, and we can see a bunch of Plasma chains. Actually, it looks like someone deployed a Plasma chain just now. And that list of Plasma chains, we will also be able to create our own Plasma chain. So if we run that Plasma chain deploy command that I just did, it will create a signed transaction and it will mine on the Ethereum network. So this new Plasma chain, we actually need to name, right? All of these Plasma chains will get nice names. So, workshop Plasma. And we're going to set an IP address or host name. So this is actually important. The burner wallet, which we will set up soon, actually pulls the IP address from the registry. And so I'm actually going to set the IP address to my localhost /API so that the burner wallet will automatically connect. You can also change it inside of the burner wallet itself, but this is just the easiest way to go about it. Now note that, of course, no one else will be able to access my localhost address, but other people will be able to, I will be able to use it, and you will be able to use your own localhost address. So now it is creating this transaction, and we can look at, my Telegram notifications. I will do not disturb, y'all. Okay, so now we are deploying this Plasma chain, exciting, and it is there. I didn't really call it my Plasma, but doesn't matter. And we will call start. So right now, first thing we'll do is we will call start, and so it will take some time. I guess now is a good time for questions, more questions. So we run our Plasma chains on Rinkeby, and then it syncs with Ethereum mainnet, or it syncs with Rinkeby mainnet. So yes, it syncs with Rinkeby at this moment, and this is because we do not want to, put your funds at risk and deploy a mainnet Plasma haphazardly. This is, against our caution, our better judgment. Any other questions? All right, well, it looks like our Plasma chain went through. So looks like our Plasma chain went through. So we have our Plasma chain address and our Plasma registry address. Everything looks good. And we're going to call Plasma chain start. So now this will boot up our Plasma operator, and we will start submitting blocks. So it's already deployed, no block number found, listening for transactions. So we have started our Plasma chain, great. Now we're going to call test swarm. This is going to generate a whole lot of test transactions, send it to the operator. Those test transactions will be included in blocks, and this will be done and, just essentially show that the thing is working. So let's do that right now. Plasma chain test swarm. And here we are. So we are sending a whole bunch of transactions. Weird, interesting. Okay, so now we have a couple blocks of transactions. So let us deposit into the chain. Well, actually, before we do that, I'm going to open up the Plasma Explorer. So I have already git cloned a Plasma, block explorer. You can go on there's a link in the workshop kind of materials. And you can go into the Plasma Explorer and you can kind of like view your own Plasma chain from there. So if I go into services and client service, then I can see that I set the address to HTTP localhost/API, and now it will connect to my local host. So I can just run npm run serve, and we should get our nice little, our nice block explorer. And by the way, we have a block explorer which is already live on the Plasma Group website. This is just connecting to our Plasma chain. And in fact, it is already on block number 2,256, which is pretty ridiculously enormous. Most of these blocks, I confess, are empty. And that is because, you know, we need more people using these Plasma chains, basically, is what that means. Okay, so we should now have the block explorer up and running. So I'm going to, ta-da! Okay, we're on our 4th block, and we have one block where we spammed a whole bunch of transactions, and we got all these transfers, which is pretty cool, right? We can see who they're from and who they're to. And we can, do it a little bit more, get some more transfers just so you can see. You'll notice that I'm sending a whole lot of transactions. These are kind of just log messages. And then periodically, I'm going to generate a new block, which is essentially a Merkle tree. And so you'll actually get to see as these, the output of the logging as it generates a Merkle tree. So, sending transactions for block 6, and boom, now it is generating a new Merkle tree. So what is it doing? It's reading all the transactions from a transaction log, and then it's writing them, it's hashing all of these transactions, and then writing a tree to a database and processing all of the different children. So here we are. Fantastic. Now, if I go here, I can see, we have a whole lot of transactions for that block. By the way, I think these transactions are in hex, so this is probably more than 348, probably more along the lines of 500 something. So right now, Plasma, I just got a question. How frequently do Plasma blocks get committed? They get committed currently at a rate of, I believe, every 30 seconds by default. This is probably a little too fast. I would say like 1 minute is probably the most reasonable. But either one technically works. It's just the more blocks you commit, the more you're going to be paying for gas, and also the larger your history proofs will get. Now what we're going to do is we are going to deposit, or we are going to transact on this Plasma chain. And so we're going to, Alice goes onto this Plasma network registry and sees, this My Plasma chain, but Alice will also see, I Love Plasma, Pentagon, Scale Today, and exclusive VI Plasma. And so I Heart Plasma, Pentagon, and Scale Today are all Plasma chains that have, been deployed technically already. By the way, most of these Plasma chains that have been deployed have not really submitted any blocks. So, caveat there, this is still early days. And exclusive VI Plasma is just to show that these Plasma chains actually, they can have their own rules with regards to what transactions they accept or do not accept. So Alice needs to choose between them, and Alice might choose this one, but can't choose this one because maybe it requires KYC, something like that. So Alice will instead choose My Plasma, and Alice will start to submit a deposit. So what we're going to do is we're going to start a burner wallet, which will point at our Plasma chain. So I already set this one up, and so if I just do npm run serve, it should actually connect to my local host Plasma chain, and we will watch that as it happens. And let's see if it's done. Haha, it has finished. Okay, so now we can look at all of these fun logs once again, connected to Plasma chain Ola. Technically, it's a different Plasma chain name, but it's both pointing at localhost. So it works. Oh, great. Successfully connected to operator. That's what we wanted to see. So now I'm going to take this address and I am going to send it some ETH. 2.1. Okay. And I'm also going to really quickly take a look at our thingy, make sure that if there's anyone who commented who wants Rinkeby ETH. Wow, no one wants Rinkeby ETH. That is, I'm glad that you're all Rinkeby whales. Now let us see. Okay, so I'm still waiting to receive my ETH. Okay, I have received it. And actually what I need to do, I have to clear this because I would be cheating. I already have some Plasma ETH on this wallet, but I haven't, haven't cleared my database. So let me just quickly delete my database and restart it. So I get a new wallet. You can actually also burn your key here, but whatever. Okay, so let me send it some ETH. Here we go. And 0.1. And let's give it a nice high gas price. All right, coolio. And so soon this will go through. So what we're going to do is we're going to deposit and send this Ethereum transaction, right? It's an Ethereum transaction, remember, to our Plasma contract, the settlement contract. And now the settlement contract is going to, it will receive all of this ETH once we've deposited it. Right now, we're just kind of sending it to the user. But once the Plasma contract gets the ETH, we are going to, subtract it from whatever account we're using, Alice's account, and then add it to the Plasma contracts account. And so that deposit will be recorded in the smart contract. And that will kind of create a virtual block. It will create a record of the deposit right here. And it will increment Alice's PETH amount, Plasma ETH amount, by whatever amount she deposited. And so let's see if we've received our ETH. In fact, we seem to have received our ETH. It seems great. Now we will deposit. So I'm going to just deposit 1,000. It says ETH right now. This is just kind of a little bit of trickery. It's really Wei. It's not 1,000 ETH. I wish I had that much Rinkeby ETH. Great. So now we have 1,000 ETH. It has shown up on the Plasma chain. This is pretty cool. And I'm pretty glad that nothing went wrong thus far. Pretty great. So now what I'm going to do is I'm going to open up another wallet so that I can send to a friend. But let's see, send a transaction. So let's do that. So instead of just Alice, that would be pretty boring if the Plasma chain was just Alice. So instead we have Bob as well. And what we're going to do is we're going to send some Plasma ETH, and that will generate a Plasma transaction. And that will, we'll send that to the operator. The operator will sign it and Merkleize it. What Merkleizing, essentially what it will do is it will create a compact block commitment. So this means that it is a fixed length number that can allow us to prove inclusion as well as actually exclusion of a set. So we have our element and we have this fixed length commitment, and with a witness, we can prove inclusion or exclusion. And this is what allows us to store very small amounts of information on Ethereum while also providing the ordering guarantees of the transactions. So you can prove that your transaction was included without storing everything on the Ethereum chain, which is great. But note that if the block has been Merkleized, it doesn't necessarily mean that it has been committed. And so we need to wait until it is mined by Ethereum. Fantastic. Now it's committed. And what we can do is we can, we can get our transactions. This is actually what's happening. It's calling get transactions on the operator. And then it's going to receive the history of the transactions which it has sent, Alice has sent. And then it will also receive the history proof of the, or the full Ethereum chain records of the blocks. And so it will validate each block individually. It will say, okay, I got the deposit transaction and I also got the Ethereum or the Plasma block commitment. So I just got a question, which is, what's the difference between Plasma Cash and Plasma Chain? Oh, fun. So really the full thing that you might say is like, this is a Plasma cache chain. So essentially, right, these Plasma cache is a design pattern for how to structure the blocks to get particular guarantees with Plasma chains. And this is something that, you know, maybe has confused a lot of people because there've been a lot of random terminology. We're trying to kind of move away from these random words, and we're just going to be like, okay, you know, here, this is a Plasma implementation, and this is, in particular, this is a Plasma implementation, which is, you know, somewhat general in that you can actually, you know, have potentially many different kinds of Plasmas. Plasma design patterns in the same kind of network, which would be very cool. So this will then, once we have validated the history, we will be able to update the block. So back to the sending transactions. Once we have validated the history, we'll be able to update the actual balances, right? We minus 50 from Alice and send 50 to Bob. And remember, don't trust verify, right? This is not, we are not trusting that the Plasma operator is doing the right thing. We're not trusting anything outside of the security properties of the main Ethereum chain, as well as our ability to be online to make sure that, you know, we can resolve disputes, which I will discuss. So now we have this 100 coins in the in our, like, this is essentially like Alice's wallet. But now what we also want to do is we want to mess around with Bob's wallet. So let's go to localhost 8080. I believe it's 8080. Nope, that is the block explorer. So 8080-801. And what we will do is we will say, okay, first I need to burn key. Toot. And great. So now, actually, let us just, or you know what? I can do localhost. Oh man. Sorry, one moment. Application, delete database, great. All right, so now I have this, I actually do have some normal ETH, but I don't have any Plasma, that's not ETH, or a Plasma PETH. So what I'm gonna do is I'm going to send to this account. So I'm gonna send, you know, 100 PETH to this account, and then it will, you know, show up right here. Over in Plasma balance 100. There we go. So, and we actually have a pending withdrawal, which is interesting. So great, we have sent to Bob. Very fun. So what if something goes wrong? This is kind of like where the rubber hits the road with regards to security. So, you know, right now the Plasma operator is being run by me. Everything's fine, right? These blocks are being committed without a problem. I have not modified the code at all. However, this is not always the case. You don't necessarily know who is creating your blocks. And so they may go rogue and they may create an invalid block. So this is an invalid block with Alice sending the operator, you know, 50 ETH, for instance. There's a transaction included in this block, which is invalid. The signature does not check out, and we've got a problem here. So according to this block, Alice's balance is 0, but we already know that Alice should not have this tiny little balance. Now, so I actually just got a question. This is to even may pull us out a little bit, but when I tested the transactions and I looked at this block explorer, you'll notice that it didn't include the deposit blocks. And the reason why it doesn't include the deposit blocks is actually, I confess, the deposit blocks are a kind of metaphorical, or it's not something that is included in the actual data structure of the smart contract. And so it's not shown in the same way. Instead, we differentiate between the deposits and the transactions in our actual implementation. But for this kind of, if you were to show everything together, it makes sense to show everything in a kind of blockchain structure, because really what's happening is we have a deposit and then we have a transaction. And so it needs to be ordered in this way. So it makes sense to show it in this chain, but it's just how we display it more generally. So we are now in the case where, back to the main show. We're now in the case where the Plasma operator is being malicious and included an invalid transaction, sending away Alice's money. And so we can't have this happen. This is just absolutely ridiculous. And so what do we need? Dun, 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 dun. We have the settlement contract. They're going to save the day. Our friendly robot smart contract. Remember, it's deterministic, which means that it's not a judge in the subjective sense that we think of maybe in our court system. So Alice signs a message saying, "Give me my ETH," because the operator is gone rogue. And so that's included in the Ethereum chain. And now the exit contract, or the settlement contract, will say exit initiated, please submit evidence if this is disputed. So the operator, if the operator, actually had submitted a real transaction of Alice's, maybe Alice would have been lying. But in this case, Alice is really not lying, and it is actually the fact that this is Alice's money. And there is no evidence which the operator is able to submit to disprove Alice's claim. And so we wait some period for the evidence to be provided, and then the contract will make the judgment, yes, this is indeed Alice's money, and send her 50 ETH. So now the balance of the operators, or the balance of the settlement contract, has decreased by 50 and Alice's increased. And the operator has not gotten anything. Good, success, attack failed. But there's more. Let's try that again, just for fun. 7 days later, right? This is quite a long time. We can do a couple things to actually mitigate this time period. One thing we can do is Alice, immediately after submitting that exit, can prove that she actually owns the coins and receives some ETH. Someone may buy her exit from her and send her ETH on the main chain. But another thing Alice can also do is not just say, give me my ETH, but also migrate me to a new Plasma chain. Basically, change my operator. I don't like this guy anymore. I want to use a different operator. And Alice can submit that transaction to the main chain. And what the smart contract will say is, sure thing. What chain would you like to switch to? Well, thankfully, we have this nice Plasma registry with all of these different chains that we can potentially switch to, right? Pentagon, Scale Today. Scale Today doesn't really look very trustworthy. Look at that snake. Oh my gosh. So Alice chooses Pentagon. And so the contract is like, done. All right, you can do this. Now, note that this transfer is still going to, there's still going to exist this 7-day dispute period. However, Alice can immediately start sending transactions to Pentagon. And what users on the Pentagon chain will do will simply check the transaction history. They'll just check to see that the transaction history is in fact valid. They will ignore this block because Alice is moved on to the Pentagon chain, and they will be able to accept Alice's transaction. So even if something were to go wrong, Alice is, doesn't have to suffer a large disruption in her service, which is really quite a cool feature. It basically shows this kind of interconnectedness of all of these different chains. So what did we actually do as a little review? Well, we deployed a large number of chains, and they all were deployed in the same kind of like network interconnected-y thing. And we actually have already had about 40 chains deployed onto the testnet, which is pretty cool. Most of them, albeit, are empty, and maybe half of them are deployed by us. But nonetheless, it's pretty easy to deploy, as I've just shown. I just added, it should be 41 now, right? So next, we've also deposited into the chain. Right now, it's ETH and ERC20s, but ERC 721s are built in basically, and the technically any state could be deposited in if you design your exit game properly. So this is really about thinking about Plasma as a general framework, great. So someone is unable to install Plasma Chain. Happy to either submit a GitHub issue, or let's we can debug it at a later time, and then send a transaction. So we can also send transactions. We just showed the transactions per second is not limited by the root chain because of these compact commitments, and actually we're able to get some really good transactions per second already. And users' funds are safe, assuming the root chain is not compromised and there is someone online to detect cheating. Pretty great, pretty great. So that is the kind of like meat and potatoes of what we've done. We essentially, we deployed everything. We, deposited, sent a transaction, and we're pretty set. But now a few fun topics to discuss. First, maybe any questions on this, please feel free to ask. And then I'll just start talking about, just fun things. So like penalties for malicious behavior. So I'll start going in and feel free to kind of pull me out. Great. I think I missed it. Someone explain why we burn the key first. So you don't need to burn the key. The issue was that I had used the burner wallet previously, and I had connected the burner wallet to my local Plasma chain, and the burner wallet will actually store your transaction history in it, right? So it'll store your balances, it'll store all your kind of information. So if you destroy the Plasma chain, as I did just earlier because I was testing out this live demo, then what will happen is you may need to, I had to remove my database and then reinstantiate it so that it would pull the new information from my thing. Now some penalties for malicious behavior, some fun little design things. So, right, like this kind of idea of kind of constraining the actors, the people who are working for you, albeit like either the validators or the operators or any party, constraining what they can do to only be something that your protocol supports and believes in. So like this is a design principle that carries on throughout Casper, throughout Plasma, throughout a whole bunch of these cryptoeconomic mechanisms. Now, one of the cool things you can do is you can say, okay, well, if the operator were to allow an invalid exit, which is later proved by the settlement contract, then you are actually able to just shut that operator down. So that means that even if the operator doesn't have a bond, which they can say, I bet $1,000 that I won't that I won't allow an invalid exit. And if you're found out to be lying, then you get your $1,000 slashed. But you can also just shut down the operator and allow users the opportunity to switch what chain they're using. And these transfers can actually be done in a relatively compact way based on the Plasma cash flow design patterns. And so this is, basically, this is a pretty cool property. So I just got another question. So on the Plasma chain, we interact with the EVM, but with Plasma Ether. When we're done doing our business in the Plasma chain, we can find out the final balance of Ether in the Plasma chain and post it on the main chain. Yes. So that is essentially it. You're able to like deposit your Ether into this Plasma chain, do some business logic, high transactions per second, whatever it may be. And then eventually you can pull it out onto the Ethereum main chain and, transact with it there. And the security of your Ether that's on the Plasma chain and on the main chain is actually very similar as long as you make sure that you are online or you trust the operator to not allow invalid exits, which I personally, don't want to rely on. But what we just talked about with this invalidity is proven, they're automatically replaced. It actually does mitigate the damages. So if one person gets harmed by a malicious operator, at least you won't be able to also have your money stolen. So that should be a little bit of consolation. So essentially, and you can also, even if you don't, you can get it back on the main chain, you can transact it there, you can even transfer it to another Plasma chain and transact it there, whatever it may be. Why do we need Polkadot/Cosmos if all custom chains opt for Plasma? It's a good question. I would say that Plasma is a legitimate, very good option for a lot of the kind of, I want to deploy my own blockchain kind of people. And there's very legitimate reasons to do this. And so I would say that maybe one of the, I guess, downsides of Plasma that you could say is that Plasma exit games are somewhat complex to reason about and implement and deploy at the current at this moment. So I actually have a little challenge here, right? Exit games are complex to reason about. And so that makes it a little bit difficult to, implement your business logic on a Plasma chain. But if your business logic is well suited for a Plasma chain, which means, maybe it only requires, simple sends and atomic swaps, or maybe you're just, an exit game guru and you're able to code in some kind of arbitrarily complicated state transitions, then, maybe Plasma is actually a better, probably more secure solution. So now, let's see, where was I? Atomic swaps on the across chains. So one of the coolest things that I did not realize about Plasma until very recently was that all of these Plasma chains happen to be connected in a very fundamental way. That means that atomic swaps are actually able to be performed natively between chains, between these operators, right? So what that means is because you're using the same Ethereum main chain, you're able to submit these, enter into what is effectively like state channels on the Ethereum main chain, and it doesn't matter what Plasma chain you're running, you can do this and you get kind of native guarantees. So if it's, within a single Plasma chain and you're doing an atomic swap, or across Plasma chains and doing an atomic swap, it actually behaves very similarly. And this actually just applies for state channels more generally. So all of these chains, you can kind of think about them as like operators that are submitting blocks and kind of deploying a new chain, but you can also think about it as, you are delegating an authority to essentially take a bunch of these like off-chain messages and compress them into a single commitment on chain, and then put it on chain. And then once you have that commitment on chain, it doesn't matter who made the commitment as long as it has been made. And that allows us to essentially like use the main chain, the interoperability of the main chain. We know that smart contracts on the main chain interop perfectly. We can use that same interoperability, but we can use it between all of the different people who are scaling using all of these different operators or committers or whatever you would want to call them. And remember, they're all non-custodial, right? So there's no, you're not trusting anybody, which means that you can just go on a long list of these committers or operators and choose one and send your money there and be more or less secure that, or say, confident that your funds are safe. Now, something that I often get asked, okay, like, is CryptoKitties possible on a Plasma chain? And so there's a big caveat here where it's like, okay, I haven't yet implemented it and I don't have a full specification for it. And so this is actually like one of the questions, like, okay, is Plasma the right solution for something like a CryptoKitties? I believe that it is in fact possible. And this is not something that I actually knew how to do until pretty recently, or at least believed I know how to do until pretty recently. And essentially what this means is you have the ability, because you have the main chain, to design your own exit games. You'll notice that I didn't go into the specifics of the exit game which we use in this testnet. And that is because that exit game, while it is incredibly, cool and it allows for light clients and it has all these properties that we really like, you can read up on the exact specification on, medium.com/Plasma group Plasma spec. So like this will give you a full kind of overview of the technicals of what we built. And by the way, just quick shout out to, and so, Ben Jones, who's actually, I think, on the call, wrote this up, and with the help of the rest of the team as well. And by the way, also shout out to Kelvin, and, Jing for Kelvin doing the burner wallet and the Explorer, and Jing for designs and a million other things. Anyway, sorry, that was a little random shout outs section. But back to CryptoKitties. So proofs of validity can be done with snarks and starks. So what we can do is we can say, what is the essence of CryptoKitties? For instance, you're like mixing coins and then minting them deterministically off chain. And, this mixing can potentially be proven using starks. And there, you can also use other forms of validity proofs, and you can also just, use centralized minting. This definitely works, right? So this is actually already very cool. So think about it as like, okay, I'm a video game developer. I want to, have a video game world where I'm minting 1,000 new assets every hour, right? There's a lot of people playing my World of Warcraft clone, and they all want to be trading their swords with each other and across plasma chains, and they want all these cool features, and they want to put their swords in state channels and make them all based on derivatives from the DAI CDPs, right? So like this is like actually things that can happen and are kind of insane, and they can happen with high transactions per second, right? They can happen high throughput, and so like this is actually pretty cool. And centralized minting, by the way, one thing is like, you can imagine that every mint has a unique ID. So like, basically it's like the Nike shoes that were created in 1992, the originals are worth way more than the Nike shoes that were created in 2019. Some challenges. I already kind of went over these. These exit games are a little bit complicated to reason about. However, one of these challenges, may have a bit of a mitigation where it would be really nice to have an exit game or a state channel simulator where we can kind of like verify the validity of these exit games and kind of like prove, maybe have some things that make it easier to formally verify properties of our exit games. And I'm currently working on a very basic simulator, but this is just the beginning. And I believe that if the tooling gets good enough, then we should be able to get very, very complicated exit games and state channels more generally, and just basically, continue to expand the features that are possible with these plasma chains. It's really important to have extensibility for this stuff. It's really important to allow, everyone to kind of build on top. And so that's what I think that this is, this can enable. The other thing is, yes, we have a slow main chain. The Ethereum chain currently processes like 14 transactions per second. This is, in fact, it is questionable whether or not this is good enough or not good enough. I don't actually know yet. I really should do the math. But essentially in the optimistic case where everything is going nicely, no operators are misbehaving, all the state channels are, going great, then the main chain currently as it stands today is more than enough to support a huge amount of plasma, traffic. And in fact, in it like an obscene quantity to the point where it actually like, scaling is like a given. But the question is, okay, how much malfeasance, how many bad things will happen? Is the main chain capable of processing all of these disputes? And, we'll see. And Ethereum 2.0, it will certainly be enough to process all these disputes. But even in Ethereum 2.0, we are going to need solutions like this plasma stuff. So I just got a fun question. So if I build a game where I expect high number of transactions per second, I should build it first on Plasma/Rinkeby. So realistically, you should one, definitely build it on Plasma. That is, basically a perfect fit because it means that your game assets will not actually have to touch the main chain. And it also means that your, running an operator, you will have pretty good guarantees about the, availability of your operator, right? You have a good incentive to keep your operator running because you're running your video game. So that's great. And so benefits, scaling today, right? That is a pretty enormous benefit. And yes, currently it is on Rinkeby, but it is, I think it goes without saying that this needs to be on mainnet. And that is incredibly important. And so, with that, love knows no borders, my corny slides, these are my corny slides. Everybody, share your knowledge. I'll try to share my knowledge. I'll, do the best I can. Hopefully you do too. Thank you so much. Shout out to Cryptoeconomics.study. Shout out to Plasma Group, all that kind of stuff. Yeah, that's mostly it. There's like 10 minutes technically if y'all want to ask questions. I'm happy to answer. You have my undivided attention for the next while. Great. So what projects? Oh, sorry. Oh, yes. Definitely check out the Telegram group, Plasma contributors. Definitely check out Plasma group generally. Group, right? Go there without a doubt. Please contribute to the GitHub. This is a community effort, and all that. And there was a question: what projects are currently being built on Plasma? Right now, there's a bunch of projects that have kind of said stuff like, for instance, Grid Plus recently in their blog post mentioned Plasma as a scaling solution. There's projects that we're in talks with that really, need to scale. And it's actually hilarious that, basically a huge number of Ethereum projects are like, oh my gosh, we need to scale now. And we really can't wait for anything. Can't wait for, Ethereum 2.0, I need it now. And so this is definitely something that is for a shorter time frame. And in fact, it is for a shorter time frame, but it is also here to stay for the long term, just because this is a good design pattern for building scalable, decentralized software. And yeah, any more questions?
Okay, guys, so while you're thinking on the questions, so let me tell you about our next workshop. So first of all, it was a great today workshop. So if you want to review Karl's workshop, please visit edcon.io/hackathon. So we will upload the video there. So you will see all the details all over again. Please, if you didn't sign up for the hackathon, sign up at edcon.io/hackathon again. And right now also I will post some information about the next workshop in group chat. So the next workshop will be at 19:30, which is 7:30 Sydney, Australia time on February 15th. So February 15th, it will be practical ZK snarks constructing for Ethereum using Rust, Bellman, and Gadget library. And that will be run by Alexandra Vlasov from Russia. So for this workshop, it will be practical webinar, and we'll focus on the practical aspects, how people can write primitive circuit and test it using Bellman and the Gadget library. Also, I will just post some links for you to pre-study for this workshop if you're interested. And again, register for the hackathon at edcon.io/hackathon. I will post all this information right now in the chat. Please ask your questions from Karl. That would be great time right now.
Cool. These workshops are great. Go EdCon. Anyway, I got another question. I'll go for another 8 minutes or so. I got another question, another versus questions versus proof of authority networks, with a little smiley face. Sounds like someone who knows their question is fun. So proof of authority networks have a entirely different trust model, right? So you're really trusting that the authorities, right, the people who are running the full nodes or the validating nodes of your proof of authority network are going to have your thoughts in their best, or you in their best interest. Essentially, what that means is they can basically do anything. There are things that you can do, like you can essentially, they can, how do I say this in a nice way? They can, rewrite history. They can censor your transactions. They can, they get basically full control. And what you're trusting, the only difference between a proof of authority network and like Google, for instance, Google is almost like a proof of authority network, is that you have, in a proof of authority network, you have multiple authorities potentially. And you maybe have, some rationale for why all of them won't cooperate with one another. However, there are actually some benefits, right? Depending on how you create your proof of authority network, you can actually build things into it that does make it more secure. So like you can make it easy for users to prove that there was something that went wrong, right? So that is an advantage of a proof of authority network over something like, Google, which makes it probably would make it quite hard for you to, prove that deleted all of your Google Pay money or something like that. And so like you can have this property, but it is very different from the property that, you know, if the operator were to do anything wrong, and by the way, the proof of authority network could be a plasma chain itself, and then it gets the really good properties that plasma chains have, then what happens is you can go back onto the main chain, or you can switch your operator to a different operator. And all of this is, you know, just really, like, at least in my opinion, much more decentralized, much more secure than proof of authority. So I got another question. Can you talk about the current state of range payments, frag, defrag, what's implemented currently, what are the limits, etc. So what's implemented currently, I probably should have gone over this earlier, is we have simple sends and we also have multi-sends, which means that we do have atomic swaps baked into our current design. What does that mean? That means that we're able to, I sign a message which says I'll exchange these coins for these coins, and then, you know, we swap ownership only if both of them sign off on it. So that's really very useful, and that actually has to do with this thing called, you know, range payments and fragmentation and defragmentation. So this is a more technical thing that hopefully users won't have to really think about too much. And that is that the current way that we achieve light client support, or really just client support that is very, very efficient, is we are able to make the client only download the transactions. Sorry, the client scales logarithmically when with the number of transactions, and the operator scales linearly with the number of transactions. What does this actually mean? Well, it means that the client only needs to download their own transactions, proofs of their own transactions, and proofs of their own transactions exclusion. And it's logarithmic in the size of the number of transactions, because essentially what you're doing is for every block, you're downloading the particular part of the block that you care about. What that really ends up meaning is that it has one really nice benefit, which is that clients don't have to be very large and operators can be massive. So you can definitely have a client that, you know, is connected to a plasma chain network that is processing 100,000 transactions per second. That's like not a problem at all. The client can totally keep up with that, as long as the operator is implemented in a scalable way, which, you know, a lot of exchanges do process 100,000 transactions per second. The annoying side effect of that is that now you have to think about all of these coins as being essentially NFTs. So there's you basically have a very large amount of NFTs, and they're all on this kind of like number line. And what you're doing when we say range payments is you're spending a range of coins, which means if I want to send you 0.5 ETH, then I might send you NFT number 100 through 150. Right? And what that would actually equal out to, you know, each one of those NFTs is, you know, 0.01 ETH, then it all equals out to 0.5 ETH. And so what this kind of does is that if you want to exit those funds, then you'll exit it in a range. So you'll say, I'm going to exit or transfer, coins 100 to 150. And that can be very succinctly stated. But if you own coins 100 to 150 and then coins 500 to 550, then that means you have to exit two different coins. That's where defragmentation comes in, right? Your coins exist on two parts of this number line, and you really want them to exist all in one big chunk so that you can exit all of your assets simultaneously. What do we do for this? Well, it's actually pretty simple. All we do is we say, okay, operator is a perfect person to suggest defragmentation requests. So essentially what the operator will do is the operator will say, oh, this user has these funds and this other user has these funds. Well, let me just say, okay, I'm going to send a message to both of them and I'll say, okay, why don't you guys swap so that now one user has these funds and the other user has, you know, this uninterrupted segment. This is a very, this essentially allows you to, exit on, a larger set of coins. And so this is kind of being done, as time goes on. However, the basic idea or the hope is that this stuff will happen in the background, and people don't actually have to know, that their, coins are fragmented or getting defragmented, and the, their stuff is fragmented along this like virtual space of numbers, right? Like that's some crazy stuff that users, developers, it's like, if you get into the weeds, maybe but you don't have to. And that's kind of what we're shooting for. We're definitely trying to make sure that like you get scalability, and you don't get the downsides of whatever weird design choices that are required for scalability. So that is pretty much that. There's actually been a whole lot of thought that has been put into these range payments, that has been put into the format of the blocks, that has been put into all of this. So really do check out the specification. Also check out, stay tuned for, what we come out with next. We've just made like leaps and bounds in terms of research. It's been, a whole lot of fun. And I'm really, quite excited to scale Ethereum, and blockchains more generally, because this is just cool tech overall. So anyway, it's 4 p.m. It's probably good for me to stop ranting. Pretty sick of my voice. So appreciate it.
Thank you very much, Carl. Thank you, everybody. Again, register for the hackathon at edcon.io/hackathon. And this workshop was brought to you by Karl Floersch, and also CryptoChicks facilitated it. Thank you very much. Recording will be available. Thank you. And goodbye.
Bye-bye.